Hello and welcome everyone. We're happy that we're all together again. In this tutorial, we will continue talking about the properties of the protection system. So fasten your belt and let's get started. The aim of this tutorial is to continue discussing the different properties of the protection system, to analyze them well, and to know what are the different tools that should be provided for the protection system. So let's go ahead. Now the fourth property of the protection system is the selectivity, and the selectivity is the ability of the protection system to recognize if the fault current lays within its zone of protection or it lays outside its zone of protection. As if the protection system managed to detect only the faults within its zone and it managed to neglect the faults outside its zone, this protection system will be a selective one as it managed to detect its related fault and it neglects the faults not related to it. For example, if a fault lays at that position, and those two protection systems manage to break the fault, the first protection system will be a selective one as it recognizes its related fault, while the second protection system will not be a selective one as it breaks the circuit when a fault out of its zone occurs. Very good. Now the fifth property of the protection system is the sensitivity, and the sensitivity is the ability of the protection system to sense the sensitive faults like the sensitive fault current. As the less value of the fault current, the more sensitive this fault current, so the protection system must be sensitive enough to recognize the most sensitive fault currents or the lowest value of the fault currents. So what we want to say is that the more sensitive is the protection device, the less fault current it can sense. Very good. Now the sixth property of the protection system is the adequateness, and the adequateness is the ability of the protection system in general, or the protection relay specially, to be suitable for its purpose that is will be put to protect. So we need the relay to be of the suitable type for the fault that it will detect. And this is because in some cases we need to detect the voltage fault in the circuit, so we will use an overcurrent relay. And in some other cases we need to detect the current fault, so we will use an overcurrent relay and it will be suitable for its purpose. And there are some factors that affects the adequateness of the protection system, and those factors are the power rating of the element that the relay will protect, as when the power rating of the element increases, this means we need a protection system with a larger power rating to be suitable for the zone that it will protect. And also the cost of the protected element, and this is because when the element we need to protect has a larger cost, this means it's an important and sensitive element, so we need a more efficient and reliable protection system to protect it. While if the protected element was a less important one, or it cost us less, so we don't need a very reliable protection system to protect it, or it will be sufficient to use an ordinary protection system as the protected element itself is not an important one. And also the third factor affects the adequateness is the effect of the element failure to the power feeding continuity. So if there is a failure in the protected element, we need to know is that failure will make the power to be cut or it will remain the power to continue flowing through the network. And an example of that is the generator, as if there is any fault in the generator, the power flow will stop because the generator is the power source in that case. So if the protected element is something like the generator, we will use a protection system that is suitable for it. And also we said, according to the importance of the protected element, we choose the type of the protection device. For example, for the distribution transformers, as we said, they are the elements that we need to protect, as the distribution transformers are not very important element in the power network, so we will use a very simple protection device, which is the fuse. Here we use an ordinary and simple protection device, which is the fuse, as the protected element itself is not the very important one. Alright. Now the seventh type of the protection system elements is the speed of the protection device, and the speed means what is the speed of breaking the circuit of the protective device. As we learned before, the protection system needs a specific time to recognize the fault and break the circuit. So this time consumed specifies how the protection system is fast or what is its speed needed to break the fault. As the more the protection system is fast, the more effect it will be, as it will let the full current to stay in the circuit for a less time. And we can take an example to know how the protection system is an important factor. Suppose we have those three bus bars and they are connected to those three circuit breakers to protect them. Now, if a fault occurs in those bus bars, like a short circuit condition for example, if the protection system that is represented in those circuit breakers is a good one to have a higher speed of breaking the fault, it may break the fault at a time of 100 milliseconds. And this means the full current will pass through the bus bars for a period of 100 milliseconds, and at that condition the bus bars will not be affected, or it will not be burned out, as the full current passes through it for a very short time. And at that case the protection system has done its job well. But suppose now the protection system takes a longer time to break the fault, which may be about 6 seconds. So this means the protection system is a very slow one to take an action, or it's not fast anyway. And here at that case the bus bars cannot withstand the full current to pass through it for 6 seconds, and it will be burned out, or it may have a failure due to the larger time that the protection system consumes to break the circuit. Very good. Also, the eighth property of the protection system is the stability of the protection system, and the protection system stability is the ability of the protection system to be suitable to take an action if a fault current occurs in its zone. And this is because we need the protection system to take an action only when a fault current occurs through its zone to have a stable protection system. And also the ninth property of the protection system is related to the economics, as we need the protection system to be an efficient one as much as possible, and at the same time it costs us less money as much as possible, or to have the least possible price. So that's for the economics. More than great. So that's about this tutorial, at which we continue talking about the protection system properties. Hope that's clear right now. Thank you for watching and see you in next tutorials.